Hi, I'm Tommy and welcome to this fourth video in my Finite State Machine in Unity tutorial series here on Table Flip Games. Over the first three videos we've built a really simple finite state machine that at present is built to sit in an idle state. What we want next is to add the ability for the non-player character to be able to start moving around the environment. So in this video I'm going to add in a new patrol state, have it be able to move to a variety of locations, then pause, wait at a location for a certain amount of time, then move again to another one. So this is going to require two things. First, I need to add in a new patrol state that has the character able to move to a collection of established patrol points, but also I need to add some new changes to the idle state to allow it to be a timed idle, whereby it will only sit in the wait state for a certain amount of time and then move again. So we'll start off, and one of the things I'm actually going to use in this video is my collection of established patrol points. Now these patrol points are actually a piece of code that I've already written, which I've got down here, and I can just quickly open this up. Now these are really simple positions in the world that are able to establish connections between them. That what they do is they actually reach out within a radius of themselves and then add a list of other connected patrol points that are near them. If you actually want to learn more about how to use this, be sure to head on over to my Unity NavMesh tutorials, which is where I actually build these for the first time and I show you how to actually make them. But if we actually go into each of these patrol points, we can see that they have a connectivity radius, and then when they actually start up, you can see this, the connectivity radius is the yellow sphere, that when we first run the code, it will actually be able to capture any of these, if any of these spheres overlap, they will be able to add these as like an adjacency list of saying, well, for example, this one here, we've got, so let's see if I can actually find it in the, there it is. So this one here is connected to that one there, but it's also connected to that one there, because those spheres are overlapping. So what I'm going to do is I'm going to have it that my patrol state is able to use these patrol points and then move around the space accordingly. So we'll start off by doing that. So if we have my idle state that's already there, and that's in my states folder, I'm going to then expand on this by adding in my patrol state. So let's go into states, add and class, and we'll create patrol state. Do its thing, and much like we did before, it's going to be a public class patrol state that's going to inherit from abstract FSM state. And also right now what we'll do straight away is I'm just going to put in the create asset menu thing that I want. Actually, let's get rid of this error, make sure it implements the abstract class, so the update state is in there, and then we're going to create asset menu. In order to do that, I'm also going to Unity Engine, so make sure we've got the using Unity Engine at the top here. And then file name equals patrol state, menu name equals, make sure I've got this exactly the same as in the idle state actually. That'd be Unity FSM states. And just going to make sure that's then patrol. And lastly, order equals 2, because I want it to be second in the list. So let's get moving with this. The first thing I actually need to do is create the set of patrol points that I need. So I'm going to say that I'm going to use my existing patrol point. I'm going to have this array of them that I'm going to be able to use. And then also I'm going to maintain the patrol point index. So I always know where I am in that array, so it knows which of the points to move between. So let's start by actually adding in on enable, and I'm just going to make it that the patrol point index is set to -1. That way I just know whether or not it's actually tried to do anything yet, because it hasn't set anything. Then I'm going to I'm going to public override, and I'm going to try and enter the state now. And so one of the first things I'm going to do for this is I just want to check whether base.enter state worked correctly. Now one of the reasons that we're going to do that is I'm going to come up here in the abstract FSM state, and I'm going to just want to make sure that the agent is aware of the navigation mesh agent that we have for it. Now this is actually something we haven't really done yet, but I'm going to add this as a new method into the FSM state. So I'm going to add a method in here that's public virtual void set navmesh agent, and we're going to pass in an instance of type navmesh agent. And what we'll do for this is we'll actually store the navmesh agent as a protected variable. So we're using the Unity engine.ai at the top here. And then, okay, well, if incoming variable not null, then make sure that we then store it. What we're going to do is we're going to say bool success equals true, and then success equals navmesh agent does not equal null. So if that isn't null, then that success value stays true, and then we're going to return success at the end. Now this is useful because I really want it so that if any state in the state machine potentially needs to use the navmesh agent, because in fact all of them are going to have to in some regard. The patrol one is going to have to be able to use it in order to actually trigger movement. The chase state is going to have to use it in order to chase the player by moving across the nav mesh. But also lastly, the idle one needs to do it because it actually needs to tell the agent to stop. So in any case, this has now become one of my tests for failing entering the state. Does the nav mesh agent exist? And what we're going to have to do then is subsequently add it in at the finite state machine level that it sets the nav mesh agent for that state. So going back into the patrol state now, if we know that entering the state was successful, we're going to then have to get the patrol points, grab and store patrol points. Now, one of the things that I'm thinking here is I'm actually going to grab them from the player rather than from the state itself, because otherwise I'd have to add all the patrol points to that state, and I might want to reuse this patrol behaviour in a lot of other situations. So I'm going to actually attach them to the non-player character, and then I'm going to pull them in a second. So in order to do that, what we're going to have to do is also set the executing agent on the state. I'm just going to declare these as virtual. I don't know whether we're actually going to need that. I'm not entirely sure yet, but I just thought, well, you know, it wouldn't hurt to have it so that when we are actually setting up these methods, they can be overridden. Cool. And then if NPC does not equal null, and then I'm going to again create another variable, which is the executing NPC. Just going to store that. I also could just as easily do this using the C# set property syntax as well, but I'm just doing it this way for this. It doesn't really matter either way, whichever way you think you feel more comfortable with. And then so next up, now that we've got these things in place, actually I'm going to add in another check. Does the executing agent exist? So we're just going to continually check. In fact, I'm going to make this two separate things. Bool success navmesh, bool success NPC, and then actually say, okay, so success navmesh is equal to that, and success NPC is equal to that, and then return the Boolean conjunction of these two variables next to each other and say, well, if both of these come back as true, then we've successfully entered the state as far as the abstract FSM state is concerned. So actually, close that. I keep accidentally going into it. Let's go back to the patrol state. And now that we've got that, what I want to say... Oh, no, hang on. I knew I forgot something. I'm going to have to add in the patrol points as a serialized field to the NPC. That way I can attach them here. And then I'm also going to add a property called patrol points, which returns them back out. So here I can now say, well, patrol points in the patrol state are equal to the NPC's patrol points. That's a good start. And then I want to quickly run a check on it, because I might be passing in a bunch of patrol points that either it's a null collection, or the patrol points dot length, the actual size of it is 0 because it's empty. So either the patrol points have been sent in and they're a null collection, or it's an empty collection. At which point what I want to do is just log an error that says, well, patrol state failed to grab patrol points from the NPC. That way I know that's the problem. And then I can return false out of the enter state. And that's going to be useful for me. So I'm going to embellish this a little bit more so that we know whether or not we successfully entered the state. Because if we haven't successfully entered the state, we shouldn't attempt to update the state later on. Now then, so we've got that, and then actually, okay, so this is fine. And then we can say, well, what we'll do is, since we know that the collection's fine, we're going to say the patrol point index is equal to, and we're going to unity engine dot random 0 patrol points dot length. So we're just generating a random patrol point. Actually, that only really works in the sense that if we are entering the state for the first time, because if we're patrolling already and then we re-enter the state, we might accidentally just select a completely random one that doesn't fit, and that's not going to help. Let me just... Oops, I've just realised there is a bug here. It's random.range. Too busy thinking ahead of myself. So yeah, this actually is only going to be useful in the event that we're entering it the first time, because if we do this every time, then it would never patrol in a route. It would always just sort of, oh, I'm just going to randomly pick something. Now, I could have it that it deliberately picks something close to it, or it deliberately picks just anything at random, but I'm going to try and mix it up here. So what I want to say is, if the patrol point index is less than 0 actually, because we start it up here at -1. And so that's kind of a nice thing to be able to detect, because in future I'm not going to do that. And then here I'm actually going to say, well, patrol point index equals, I'm going to get it to move forward 1 and wrap around the collection if it needs to. So that'd be patrol point index +1 close bracket modulus patrol points dot length. So if you've never seen this before, the percentage there, that's the modulus operator, and what that's telling me is to calculate the remainder relative to the length of patrol points. So say if there is 5 items in patrol points and patrol point index has now reached 6. Oh, actually no, that doesn't work. Patrol points dot length would come back, yeah. So we're going to say, right, whether or not if this item +1 is larger than patrol points dot length, what it then does is it wraps it back around by calculating the remainder. And what that essentially does is it stops patrol point index from going off the end of the array. So if we go 0, if patrol points dot length was 5, it's going to go 0, 1, 2, 3, 4, back to 0 again. And that's a really nice trick to be able to have. It guarantees that regardless of how big the array gets, I'm not going to accidentally go off the end. Now, provided that we've got the satisfactory destination set up, the last thing I actually need to do when entering the state is I want to set a destination of the patrol points at the patrol point index. I want to say, right, I want to go to that location. So I'm actually going to base this on an existing bit of code that I already wrote back in the navmesh tutorial series, where I'm going to write this private void set destination method, and it takes the patrol point as an argument as the destination, and if the navmesh agent null and the destination isn't null. We're going to assume that this is fine, but this is me. I'm very pedantic that way. I'll often go away and just run these null checks again and again and again, because you never know, something from an external force could have actually changed something in those variables at some point. So I'm always just naturally cautious. So navmesh agent dot set destination, and I'm going to say, right, the position of that patrol point. Smashing. Now, the only thing that's missing is in the update state. What we actually need for the update state is I need to be able to get it to check whether it is within a certain range, and at which point it's going to transition back out of this state into an idle state. Now, this actually has two things. First, we have to do the condition check, but also we haven't really figured out yet how a state is able to force a transition in the state machine, and I'm actually going to get it in this example because it's quite small. The state itself calls the state machine and tells it to transition to another state. So what we'll do here is, and there's actually like still something I need to do here, need to make sure we've successfully entered the state. This is actually a potential issue down the line, which I should really actually make sure is okay. Oh, I actually need to fix this as well, because that should be returning true now. And yeah, what we'll actually do, let's quickly fix that now. So I'm going to go back up to extract FSM state, and I'm going to add a property to it. Public bool entered state. And you can only set it internally. Now, what I want that to do is I want to be able to say, when I'm in a given state, that it successfully entered it. And that's on purpose, because if I'm in a state and it doesn't enter the state properly, I don't want it to continually run the update or try and exit the state, even if it didn't successfully enter it. So if I go back into idle state, I'm going to say, yeah, entered state equals true, and I can actually just say return entered state here. And then in patrol state, I'm going to change it up here, and yeah, I think that's what we could do. Is I could actually say here entered state equals false, but also entered state equals true if it reaches that point. Actually, what we can do is we can change that so it says else. So in the event that there was actually some valid locations, we're going to do all this logic here. Actually, you know what? Let's just change this a little bit. I'm going to say entered state equals false at the top. So I'm going to assume by default it didn't do it. And then at the end, it'll only do it if it actually successfully set the destination, at which point we then return the entered state as true or false in this instance. So then when I'm in the update state, what I can do is I can say, well, if entered state, we're going to put some logic in here, but if it didn't do it, then I don't have to care about it. So if we tried to enter into this state in the state machine and it didn't successfully enter it because there was some sort of problem up here, then I know for a fact this logic isn't going to execute. Okay, so let's do this, and then I'm going to say if vector3.distance, and I'm going to take it from the navmesh agent's position, because I'm going to use the navigation mesh agent as my way of understanding where this character who's executing this state in the FSM actually is in the world, and I'm going to compare it against the position of the patrol point. Patrol points at patrol point index dot transform dot position. I could maybe make that a little bit cleaner, but hey, it's going to be fine for what I'm doing. Is it less than or equal to 1 float? If so, then we've reached the destination. Now, at which point I actually need to make sure that we have the FSM so I can call it. So I'm going to add this again into up here. I'm going to add in another protected variable, which is the finite state machine. And I'm going to make it so that in the abstract class we can set public virtual void set executing FSM. Finite state machine FSM. make sure that that imports the correct using for it. There we go. And then say if FSM does not equal null, FSM equals FSM. So there's two things I need to do here. I need to make sure, well actually there's three things I need to do here. I need to make sure that the finite state machine sets the navmesh agent, the executing FSM, and the executing MPC on a state, but also I then need to go back into patrol state and then tell it, okay, FSM.enter state. Now, here's the, previously, in the last example, I passed in the specific abstract FSM state instance that I wanted, but I'm not going to do that here. I'm actually going to create a new enum and pass in that and say I want to pass in FSM state type .idle. So to get that to work, I'm going to add in a new class which is called, oh no actually, well let's not do it there. Let's do it in the abstract FSM state. We'll have another enum at the top here. Public enum FSM state type, and I'm going to have idle and patrol. Let's see if this compiles. There might be a couple of bugs already in here that I need to fix. Yeah, so here we go. We've now got this error because it's saying, well, we actually don't allow that. So I need to create a new version of this method. That is FSM state type and state type, which we're going to pass in. Now, here's a fun thing. What I would really like to do is have it so that the finite state machine knows all the different states it can have. And then what we do is it knows the type that's corresponding to that particular state. And then what I can do accordingly is I can then say, right, well, I need to enter that particular state. Can we find that state in the project? And then we're going to like kind of put all that together. So to do that, we'll start off, actually there's a few things we need to do in the finite state machine, don't we? So let's start by creating a dictionary of finite state machine type and abstract FSM states. I'm going to call that FSM states. And I'm also going to create a list of, I'm going to expose this list that I'm going to make as a serialized field, and it's going to be of abstract FSM state, and I'm going to call it valid states. So these are the states that we're going to add into the state machine and say these are the states I want it to be able to use, and then what I'm going to do is I'm actually going to store them using a dictionary. Now a dictionary requires a key and a value, and the key that I'm going to use is the enum. So each state is actually going to tell me what type of state it is using the enum, and then I store them there. And then I've got this kind of like quick lookup function, which will actually be really useful for me at a later date. So first of all, yeah, let's set up the FSM states. FSM states equals new dictionary, that type. And then what I'm going to do is I'm going to iterate through each state in the valid states list. And I'm going to tell it state.set executing FSM is this. We also could probably do all the other things too, actually. We could set the executing non-player character, as well as state setting the navmesh agent. Now I actually need to get those. Right, let me, so first of all we need, that requires, what does that one require? That requires the MPC, and that requires the navmesh agent. We need to get the navmesh agent. Navmesh agent. Navmesh agent equals, and yeah, well the thing is, we actually know that this is going to be attached to the same game object because the NPC requires that it has both a navmesh agent and a finite state machine attached to it, which is quite handy. So I'll be able to say this get component navmesh agent. I know it's going to be there, which is lovely. Actually, I'm also going to just grab the MPC because that's also going to be attached to the same game object. Okay, so let's quickly add the navmesh agent in here. Nice. Actually, there's a new problem that's emerged here that I didn't think through. Is that right now this is actually going to have trouble finding NPC, even if I actually have using, and then if I actually go into my code and actually try bring it in by hand, it's actually going to be problematic. And one of the reasons for that is I actually named the namespace the same as the class. Isn't helping. See here. That the namespace for NPC patrol point and NPC is the same. So I'm going to just change this here. That's going to make my life a little bit easier. Yike. Didn't see that happening. There we go. And that actually fixes the problem because now it can differentiate between NPC the class and NPC the namespace. Phew. There we go. So, what's your problem? Oh, there's now actually going to be a bug with that, isn't there? Not doing great today, am I? Here we go. That's better. There we go. So we're now setting the executing FSM, we're now setting the executing NPC and the navmesh agent. This is all very handy for me. But also what I'm going to do is I'm going to FSM states.add state dot, and I'm going to actually have a state type. And then that state. So what I need to do is go back into the abstract FSM state. We've now got this FSM state type, but I also need to add in the state type property, and I'm also going to add in a protected set for that so that each class can dictate what type it is. So in the idle state, I'm going to come back in, and in the idle state I'm going to override on enable and actually say state type equals FSM state type dot idle. And then subsequently in patrol state, I'm going to go back up. Fix that problem that I created myself. That unnecessary using command. And on enable, I'm also going to do the same thing for patrol. So state type equals FSM state type dot patrol. Right. Getting back to point. So this is great now, because one of the things I can then do is back in the finite state machine, when I want to transition, and it says, oh, I want to enter that particular state type. Say, all right, fair enough. We're going to start by actually saying if FSM types, if the FSM states, the dictionary, contains the key of that parameter that's being passed in, does it contain a key for idle or patrol, then we are going to have this. Actually, what we'll do is we can then say, okay, grab the FSM state from the dictionary. I'm going to call it next state equals, and just going to grab that key, say okay, we'll get the value in the dictionary that corresponds to that key, and then I can do two things. First of all, I'm going to tell the current state to exit itself, and then the next thing is we're going to enter the next state using the existing code we've already got. And because this one is passing in an abstract FSM, when we call this, we're actually calling this. So it's going to do all the code that we need right there. Actually, what I should probably do is add in the ability to exit the state here and say, well, if current state not equal null, then that. Alright, I think that's going to do most of the things that we need in order to do what we want for this. Lastly, let's just double check that I add in. We're now going to enter the FSM state for the idle. Right, great. There's only one thing that's missing, and we actually need to go into the idle state for that. So the idle state needs to have the ability now to time out, where after a certain amount of time we then say, okay, I want you to transition back out of this into the other state. So let's start by adding the duration. Three seconds. 3 seconds is a good wait time. We're also going to need the total duration that it's been active for. So when we enter the state, what we'll do is entered state equals base.entered state. I'm going to set the timer to 0 here. Now in the update state, we can check the timer only in the condition that we've entered the state. Increment the total duration by the delta time. Maybe print out that idle timer, actually. Lastly, we then need to check whether we've passed the idle duration and then force the patrol again. At which point, trigger the FSM to enter the state again. So that should be all the code that we need. The only thing I need to do is I actually need to go in and I need to set up the patrol points and make sure that the patrol state is able to grab them. That's the one thing that was missing. We've got the npc.patrol points. Yep, so I need to set up the patrol points in the non-player character, and I also need to add all the states to the state machine. Okay, there we go. So we've now got patrol points appearing in the NPC script. I'll quickly lock this. I'm going to drag and drop all these NPC points into that collection. Nice. And then also I need to create a new state here. So create Unity FSM States Patrol. So we now have a patrol state. Nice. And also you can see here the idle state now has the duration on it. And one of the things we could in theory do is go back and change the code to add like a Boolean ticker that dictates whether or not the timer's even used. And then you could actually have multiple copies of this idle state scriptable object, which have different configurations for what you want. So you could have one of them that's maybe got a really long duration or a really short duration, or, you know, other things that you could actually get it to respond to. This is all very early phase given what I'm trying to do here, but, you know, it'll get us to where we want to go. And then lastly, I need to go back into the finite state machine and I need to add the valid states. So I'm going to lock this and we're going to add in valid states here. And then actually what I want to do is I want to make a change, because right now this is still public and I'm not happy about that. So I'm going to go back in here and I'm going to get rid of starting state for now. What I'm going to get it to do instead is I'm going to tell it enter state. I'm going to use the FSM state. I'm just going to tell it to enter the idle state by default. And then that helps it get up and running. And then in theory, the idle state should then allow it to transition into patrol once it has actually reached its duration and it's finished and it's done what it needs to do. Well, hopefully that's going to work. Let's give it a shot. So we're in the updating and the idle, and then we move. There we go. It has now exited the idle. Oh, actually something I didn't really... Oh no, there we go. It's okay. It kind of did what we needed to do. One of the things I haven't really figured out, or I haven't really ironed out, as you can see, so it's now operating between the two. One of the things that is actually interesting that I haven't really factored in is that the idle state isn't stopping the nav mesh agent. So one of the things I might need to do is add braking to the behaviour of the patrol state so that, well, no, the idle state rather, so that when it actually gets to where it needs to be, it will actually properly stop the nav mesh agent and it doesn't keep running around like a fool. But here we go. Taking a couple of videos, but this is it. We actually have the structure in place that the system is oscillating between an idle state and a patrol state, and it's able to interface with the navigation mesh agent, but also that we're able to, from a design level, dictate what patrol points we want that guard to use, that character to use, and that makes it a little bit more extensible rather than having those patrol points in the patrol state itself, because otherwise we'd have to reconfigure it for every possible guard or character we might have in this game. Instead, we've got it running out here at the NPC level, and that would be much easier for us to prefab and change and play about with in the editor. So we still have a lot more work to do here, but the next main phase is adding in the chase state, as well as balancing a lot of these behaviours to do something more interesting. For now, however, this has been part 4 of the Finite State Machine tutorials here on Table Flip Games. Don't forget to like and subscribe for more game dev tutorials, and join our Patreon for access to all of our source materials. Thanks for watching, see you in the next video.